we had what I think was a pretty robust conceptual approach to AGI in Opencog Classic. We wrote a bunch of books and papers on it. There were many research problems still to be resolved to get from here to AGI, but we felt we had a framework within which we could explore these research issues, right? But we were finding not enough scalability in the Opencog Classic system, and also not enough usability in a number of respects. Hard to onboard new developers, but also hard to interface Opencog with external libraries like ones running deep neural networks. So it was a horrifying and painful decision to rebuild Opencog from scratch, because I knew it would take a long time and just take a lot of work, and we'd all rather be building AGI than building tools on which to build AGI. On the other hand, it's being a fun and interesting process on its own. I mean, we now have like the first sort of early alpha version of the distributed atom space of Opencog running with a Flybase, a database of knowledge about fruit flies loaded into it for our collaboration with Rejuve on analyzing DNA of long-lived flies and porting knowledge from that to humans. And we have a pre-alpha version of the MeTTa interpreter from the work mainly of Alexey and Vitaly Bogdanov, and we're still revising and improving that, but it's pretty interesting, pretty sophisticated, and there's been a lot of math done to figure out how to map various AI algorithms optimally into the MeTTa language for efficient execution. And then, two sort of more exploratory directions for radical scaling up of execution speed. So one of them, as you mentioned, is making a chip customized for pattern matching, which I led the design on, but then to actually get it built, we're working with Rachel St. Clair's company, Simuli, and that's got its own trajectory associated with it. Building hardware is even slower than building software, although faster than ever before.
Faster than it used to be. Yeah.
Then the other thing is we're collaborating with Greg Meredith, who was the mastermind of the R-Chain blockchain, and he's working on translation from MeTTa into a new version of his Rolang programming language, which has two advantages. Rolang was already instrumented to be a smart contract language for use in the R-Chain blockchain, and Rolang appears particularly good at running stuff fast on concurrent processors, so like on the GPU with multiple processors. So that if all goes well will be ready well before Rachel's AGI chip, right? So I mean, it'll be like you can run MeTTa on the main MeTTa interpreter, which has maximal flexibility. You can sort of compile MeTTa into Rolang, which then lets you do smart contract stuff and gives you improved speed on concurrent hardware. And then once the chip is ready, then you can do pattern matches against data stored on chip, which can be super fast, right? So that there's a lot of possibilities here, and I think even without the chip, and really even without Greg's Rolang stuff, we already have a framework that will be able to scale up the Opencog AI approach so that it sort of can be a worthy counterpart to large language models and deep neural nets, and we can get some synergetic AI going. And I think this will be useful all across the map.